So the last time we looked at count vectorizer, which essentially just count the frequency of how many times each word occurs in each sentence. Well, today we're going to look at TFIDF, which is essentially term frequency, inverse document frequency. We'll talk much more about that later. But basically the idea is that from the count vectorizer, we know that we do not know how much a word essentially contributes, how significant it is to the sentences, such as we know that the quick brown fox. How do I know that how important fox is in this sentence and how insignificant the is to this sentence? Based on the count vectorizer, we only know that there's a count of the and the count of fox, but we do not know like fox has a significant meaning to these sentences as compared to the whole document, and the has no significant meaning compared to all these sentences because it actually appears in all these documents. So we can imagine that something that we want from here, so maybe the brown value that plays maybe a 0.5 significance, and we know that the fox plays a much significant value, maybe I'll say 0.9. This is just an example. And maybe the has no meaning since it does appears in all the sentences, so it does not contribute any significant meaning. So it might actually just be a value of 0, etc. So we can see that this is the actual difference between TFIDF and the count vectorizer. Now let's look at the first part of TFIDF, which is the term frequency, which essentially is just the count of the current word, like given a word, like if brown fox, the brown word, and over the number of words in a sentence. So for like, as an instance, in sentence 1, there are 2 words in this sentence. So the term frequency, the denominator, I think, will always be 2 because there will always only be 2 words in this sentence. So we can see that for brown, it occurs 1 over the 2 words, so it is 1 over 2, and then the same for the fox, and there's no dog, so it will be 0. And then the same thing for sentence 2, 1 over 2 for the brown, and then there's no fox, and there's 1 word of dog over the 2 words, so 1 over 2, and then brown fox dog 1 over 3 because there are 3 words, and then 1 over 3 for the fox and 1 over 3 for the dog. As for the inverse document frequency, the formula is actually the log of the number of sentences over the number of sentence that contains the word. So in our case, since we have 3 sentences, this number of sentence will always be 3, and the number of sentence that contains the word, for example, when we look at brown in sentence 1, we know that the IDF would be the log of 3 over 3 because brown occurs in all 3 of the sentences. So this would be log 3 over 3, and we know that the purpose of the log is to differentiate and also dampens the value. For example, we know that the log of 1 is equals to 0. So in this case, we know that brown plays no significant value as the IDF is 0, and if it weren't for the log, we would not know that this actually equates to 0. So as for the fox, the IDF would be the log of 3. This will always be 3, and fox occurs in 2 over the 3 sentences, so this would be 2, and the IDF would be the value of this log, and then the same goes for the dog, right? And also something that I mentioned about the log dampening the values. So that would mean that maybe if we were to have a very large document and a lot of sentences, let's say we have a million sentences, I don't know, and the word thus appears in maybe like let's just say 50 of the sentences, this would get us a very, very large, I don't know how much value, but putting it under the logarithmic, it will turn down the value to a much smaller value maybe in like maybe 19 or something else, but it will make the things less complicated by giving us such a large value like maybe 20,000 or something. Now that we know our term frequency and our inverse document frequency, we can count our TFIDF by just multiplying both of these values together. So for example, when we look at brown in sentence 1, we know that the values will always be 0 no matter what, because the IDF is 0, so we can know that it will always be 0 for the case of the second sentence and also the third sentence. And when we look at the fox, we know that the term frequency for the fox is 1/2, and then the IDF for fox is the log of 3/2, and this would be the TFIDF value for fox in sentence 1. And as for dog, we know that the term frequency is 0, so even though it does have some values for the IDF, but it will also equates to 0. So now we know that fox in sentence 1, we know that fox plays a significant value because we know that brown is 0 and dog is 0. So we know that this sentence is about the fox. So the same thing happens to sentence 2. We know that there's no fox here, so this is going to be 0, as you can see in the term frequency. And as for the dog, the same thing, just like the case of fox in sentence 1. So it will 1/2 over the log of over here, refer to it, so it's 3/2. This will be the TFIDF value for dog. So we know that in sentence 2, dog plays a significant value for this sentence, as compared that we know that brown plays no value because it does appear in all of the sentences, so it is not special to any of the instance of any sentences, and there is no fox in this sentence, so dog plays the much significant value. We know that this sentence, we are talking about the dog. So as for the sentence 3, this will be 1/3 over the log of 3/2, and then 1/3 for the log of 3/2, same thing. So we know that the fox and the dog both play an equal value to this sentence 3. So remember that we actually did the spam and ham email classification on using our account vectorizer, and that time we actually obtained very good results, actually 98.91% accuracy. But this time, using the same data set, the same thing, but with using the TFIDF Vectorizer, we obtained a slightly even better accuracy at 98.96% accuracy, but I believe that these changes can actually be reflected on a much larger data set. I think the Databricks document here do talk about it. You guys can take a look. I think it did mention down over here like how it gives, well, in this Databricks document, it talks about topic modeling instead of classification like we did for the spam and ham, but it does clearly shows the better results of the topic modeling by using the TFIDF. So make sure to check it out, and I do think that this document is very, very good. So shout out to the YouTuber that did this. So to wrap things up, the few key takeaways about TFIDF is that the advantages are that it can tell the weights or the significance of the words to the sentences, and it can remove the stop words, as we can see that like we know that the brown or words that are frequently occurs have no meaning to the whole document, and it can tell the similarity of the documents, since we know, like, by telling the values of each word, we can tell the similarity of documents. But the bad thing, the downside, is that it cannot capture the semantics, the meaning of the words. Like, let's say fox, we cannot tell what fox is. We do not know that it is an animal. We do not know that it is something near to mammals or cats or something like that. And to do that, maybe we can use word embedding, which is something also known as word to vec. So maybe the next time we will talk about word to vec. All right, see you. Bye bye.